we're going to be learning about projectile motion. This is the third video in the mechanics series. And projectile motion is essentially motion of any object that is moving horizontally under the influence of gravity, gravitational acceleration. And really the essential component of projectile motion is to be able to split the motion into horizontal and vertical components, because really you have to treat the motion in the horizontal case separately from the vertical case. Horizontal motion is slightly different from projectile motion only because there is no vertical acceleration. So here we can see that without falling downwards, the actual motion of this ball thrown sideways is identical to this ball rolling sideways. They go the same distance horizontally. Well, whenever we have an object moving in a constant velocity, as is the case with this ball rolling, well, we know that the velocity is constant, so there is no acceleration, and therefore the velocity can also be equated from the change in the distance over time. In this case, the horizontal motion can be modeled with only v, d, and t, and this is totally true for projectile motion. Horizontal motion has only these three variables. What about in the vertical? Well, in vertical, you can compare the motion with free fall, an object that is just falling straight down. Here we see that the height of the objects are at identical height when compared at identical times. So what do we see here? Well, the object is accelerating. The velocity is not the same. It's falling at different rates at different times. Therefore, the velocity at the start is not equal to the velocity at the end. We must have both the initial velocity and a final velocity. In addition, anytime we're working with vertical velocity, we should always start by just acknowledging that the acceleration will be negative 9.8. Anytime, you should just fill that in straight away. You don't need to be given this. You just know that the acceleration is negative 9.8 meters per second squared. Why is it negative? Well, it's going down. Any acceleration down, any vector that is going down, whether that's velocity, distance going down, or displacement going down, or acceleration going down, it's always going to be negative, as long as you say that going up is positive. So how can we distinguish between horizontal and vertical parts? Well, here we see the velocity of a ball thrown at 18 meters per second at an angle of 30 degrees. Well, this is not horizontal or vertical. What we need to do is we need to draw a right triangle so that we can split into horizontal and vertical components using our trigonometry functions. SOHCAHTOA, so sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. SOHCAHTOA. To solve, we want to draw a right triangle. Now, which side is the 18? Well, 18, the velocity will always be the hypotenuse, which is the longest side of the triangle, or my preference is to say the hypotenuse is the side of the triangle that is opposite of the right angle. It's always opposite of the right angle. In this case, the hypotenuse is 18 meters per second. Okay, so we know the hypotenuse is 18 meters per second, but how can we use this to find the horizontal and vertical components? Well, it sometimes is very helpful to label our right triangle so that we can find the opposite and adjacent sides. In this case, we can see that the vertical part of the triangle is opposite of our angle, and the adjacent part of the triangle is our horizontal component. Right? So our adjacent is horizontal, vertical is opposite, in which case we use the sine function for our vertical component, which would then become sine 30, sine of our angle, times our hypotenuse, 18, which will give us 9 meters per second upwards. 9 meters per second is our initial velocity in the vertical. What is our velocity in our horizontal? Our velocity in the horizontal will be the cosine of 30 times 18, which is our hypotenuse. And this velocity is not our initial velocity, this is our constant velocity. So this is v. v is 15.6 meters per second to the right. So that's fine. Now for finding the vertical and horizontal parts, but how do we find the total velocity if we start, or if we end up with the vertical part and the horizontal part? How can we find the total velocity? Well, in this case, we need to find the resultant. The resultant is simply the hypotenuse of a right triangle if you add your horizontal and your vertical components together. And we can calculate this most easily by using Pythagoras. A squared plus b squared equals c squared. Or in other words, the hypotenuse or the total velocity is equal to the square root of the vertical squared, 3 squared, plus the horizontal squared,